Welcome to today's video lecture on CS203 Logic System Design based on the KTU syllabus. Today's topic is 1's complement and 2's complement. Let's move to the topic. Today I will going through these contents: signed magnitude representation of binary numbers, 1's complement and 2's complement. What do you mean by signed magnitude representation of a number? We are all familiar with the signed magnitude representation of decimal number using the positive sign and negative sign. A plus or minus sign to the left of the number indicates whether the number is positive or negative. For example, plus 12 indicates it's a positive number, or minus 12 indicates it's a negative number. Okay. In the binary signed magnitude representation, the leftmost bit is used for this purpose, or for this sign, which takes on the value of 0 or 1. 0 is used to indicate the plus sign and 1 is used to indicate the minus sign. The remaining bits contain the absolute magnitude. Here is the example for the signed magnitude of the binary number. First of all, we have to find the binary equivalent of decimal number 12, that is 0001100. If it is positive 12, we have to add 0 in the leftmost of this number. So we get 0001100. Okay. For negative 12, we add 1 here in the leftmost. So we get 10001100. This representation is known as the signed magnitude representation. Next one is 1's complement representation. In 1's complement representation, we convert all the 1's in the number to zeros and all the zeros into 1. It's defined as the value obtained by inverting all the bits in the binary representation of number, or swapping zeros or 1's. The 1's complement of the number then behaves like the negative of the original number in some arithmetic representations. Within a constant, the 1's complement behaves like a negative of the original number with binary addition. Here is an example for the 1's complement representation. First of all, we write the plus 12 into the binary. So 00001100, the leftmost 0 represents the plus sign. So for computing the negative 12, we use the 1's complement representation. So we invert all the bits. So we get convert 0 into 1, 0 to 1, here 0 to 1, and 0 to 1, here 1 to 0, and 1 to 0, and 0 to 1, 0 to 1. So we have to invert all these digits to form the 1's complement representation. So we get 111001 as the negative number of the original number. This method is known as the 1's complement representation. But there is a twist for 1's complement representation. Consider the example of 0. Using 1's complement representation, we have two representations for the number 0. Plus 0 means 00000, like that, and we have to convert this plus 0 into minus 0 using 1's complement. So we get 111111. So the plus 0 and the minus 0 is different. So we have two different representations for the number 0 here. This is just twist of 1's complement representation. This can be eliminated using another technique. It is known as the 2's complement representation. Let's move to 2's complement representation. Okay. In 2's complement representation, there are two steps. In the first step, we have to convert the binary number into 1's complement. That is, complement all these bits in the number, in the first step. In the second step, add 1 with the 1's complement. If the addition results in carryout from the most significant bit of the number, discard the carryout, because here in the binary addition we have 1 plus 1 is equal to 0 and carry 1. So sometimes there is a chance to get the carry 1 in the leftmost side. So when this a situation arises, we have to discard the carryout. Okay. And this is the example for 2's complement representation. This is the example for the representation of 0. Consider forming the negative of plus 0 using 2's complement representations. Here plus 0 is equal to 0, 0, 0. It's an decimal equivalent number 0, and it converted into the binary equivalent number of 0. And once complement is 0 produces 1, 1, 1, 1, 1. Then add 1 to this 1's complement form and we get 0, 0, 0, 0, 0 here, and the positive 0 and the negative 0 is same. So using 2's complement representation, we eliminate the above problem with the 1's complement representation. This is the advantage of 2's complement representation. So in 2's complement representation, first of all we calculate the 1's complement and add 1 to it. So we get the 2's complement representation. All of you got the idea? Hope you understand the 1's complement and 2's complement and about signed magnitude of the binary system. Thank you all.